Hello, my mathematicians. This is the first video to go along with 3.1a, which is application basics, which basically means word problems. So this is going to be all different types of word problems for the three different types of functions that we've been focusing on. So we're actually just going to jump right in with a really meaty problem. So we're going to say the tables below give the amount of money in bills and pages account over the months. And here are the two tables. So T, which is months, and B of T, which B is going to stand for bills. So this is bills account. Okay, and we have 0, 1, 2, 3, 4. And we start with 5,000. And we go to 5140. And we go to 5,283.92. And we go to 5,431.87. And we go to 5,583.96. And then we have T, and we have P of T, again, months, but this time it's pages account. And we have 3, 6, 12, 15, 24. And we have 23,000, 21,000, 17,000, 15,000, and 9,000. In the long run, we're going to want to know, when will Bill have the same amount of money in his account as Paige? When will they both have the same amount in their account? But in order to even get to that, we have to decide what kind of relationships are these. Okay, remember, math is about looking for the patterns. So we need to decide what kind of pattern we're observing here. So the first thing that we really need to answer, and again, I've mentioned this in previous videos, this is a word problem. The first thing that you should answer is, what is the input here and what is the output here? It will make your life easier. In this example, because we're starting with a table, the input is always listed first. So I know the input is T, which is months, and I know the output is the amount in the account, and that's in dollars. Okay, so that's the first thing you should list no matter what your goal is for the rest of the problem. Now, we need to find a function to model Bill's account. So let's focus on Bill first, okay? First things first, let's just observe some trends. The input is increasing by ones, okay? The output is increasing, so Bill is gaining money, he's making money. But let's just take a look at these numbers. I can tell that this is not a constant change because it starts out whole and then there's change. Okay, there's cents, there's decimals added to it. That's not going to be the same change for every one. So this is definitely not linear. I can jump in then with the exponential test. Okay, what would the exponential test be? So for Bill's account, I want to know what f of 1 divided by f of 0 is. Remember, always divide sequential points, okay, sequential outputs. So I'm going to divide 5140 by 5,000. and I wind up with 1.028. All right? Then I'm going to divide f of 2 by f of 1. Okay, again, it's just consecutive outputs. So that's 528392 divided by 5140. All right, you're going to put this directly in your calculator, and that's 1.028. And then you're going to do f of 3 divided by f of 2. I don't care if you use this notation, by the way, as long as I know you're dividing consecutive outputs. This is going to be 543187 divided by 528392. Put this directly in your calculator. It's not going to be exact, but it's going to be really, really close. Okay, so just to illustrate what we get here, 543187 divided by 528392. Okay, it's not exact, but it's only off by 0.000045. Okay, that's essentially 1.028. All right, it's not like one of the ones in the previous videos where it's not close. Okay, this is very, very close. Okay, and the last one, I want to divide f of 4 by f of 3, which is 558396 divided by 543187. And again, it's not exact. And I will show you what the number comes out to be in case you're doing this as you follow along. Okay, this is what the number actually comes out to be. But look, it's 999, okay? So that's essentially 1.028, okay? So they are pretty much the same values. The reason why these might be off, okay, is because we have to round the cents, right? We only take cents out to 2 decimal places. So maybe that's just from the error in rounding the cents, okay? That could be. So I do have a constant multiplier or a constant factor. So that tells me that the factor is 1.028. And can I look up here and spot the y-intercept? Yes, I can. The y-intercept is 0, 5,000. So I know that the function for Bill, which remember is b of t, try to keep consistent with the variables, okay? B of t will be 5,000 times 1.028 to the t. Okay? So this is all your work for Bill's account. So I don't have that much room here, but I don't want to turn the page just yet. So hopefully we can squeeze this in. Okay? I want to zoom out a little so we can still see the values up there. All right, now we want to do the same thing. Find a function for Paige's account. Okay. I go up and I look at Paige's relationship. 3, 6, 12, 15, 24. It's not the same, all right? But let's list the changes anyway. So from 3 to 6 is a change of 3. From 6 to 12 is a change of 6. Then I'm back to a change of 3. And then I'm out to a change of 9. Okay? Let's look at the changes here. First, let's observe the trend. Paige is losing money. Okay? The amount in her account is going down. So first, she loses, and that's shown by a negative, $2,000. Then she loses $4,000. Then she loses $2,000. And then she loses $6,000. Okay? These numbers are not the same. Well, 2 of them are. She loses $2,000 over 3 months. She loses $2,000 over 3 months. Okay, those numbers look pretty good. I need to see if they're the same as losing 4,000 over 6 months. All right, or losing 6,000 over 9 months. So I want to see if these changes are the same, which means I'm looking at comparing the rates of change, okay? So I want to know if negative 2,000 over 3 months, okay, gives me the same thing as negative 4,000 over 6 months, and the same thing as negative 6,000 over 9 months. If I were to simplify 4,000 over 6, these are both divisible by 2, and I would get, I'll just do it on the bottom, negative 2,000 over 3, be the exact same thing. Look at 6,009, okay? They're both divisible by 3. If I divide top and bottom by 3, look at that, I get negative 2,000 over 3. So yes, all of the rates of change are the same, and so this is linear, and I know the slope because that was that calculation. So negative 2,000 over 3 is my slope. I am not given the y-intercept in Paige's situation. So I can do one of two things. I can extrapolate, okay, I can go back and say, well, wait a minute, if this changed by 3, I would get 0, okay, if I go back one step. And if this lost another 2,000, then that means I'd be at 21,000. So I could use the pattern, okay, my knowledge of the pattern, to know that the y-intercept is going to be 0 and 21,000. Okay? Oh, I'm sorry, I have to add it on because I'm going backwards. So 0 and 25,000. Okay, pardon me. I have to go backwards. Okay, there would be a 0 here. And this has to be a higher number. So add on the 2,000, right? That's where 25,000 is coming from. And again, it has to fit the pattern. Okay, so if you're decreasing going this way, you have to be increasing going this way. But we also have a formula that we can use when we don't have the y-intercept. If we don't have the y-intercept, we're going to use point slope form, which is y equals m times x minus x1 plus y1. I'll use the first point here. Okay, it doesn't matter which one you use. We've seen that before, but I'll just use the first one. And I'm going to say it's y equals negative 2,000 over 3 times x minus 3 plus 23,000. And then if you wanted to simplify this to get it into slope-intercept form, you could prove to yourself that you would wind up with 25,000 for B, okay? But these are good enough. Remember, though, it's not x and y. So if you can remember, always convert back, this is Paige's account, to the units or the values that they were using. So this is P of t is negative 2,000 over 3 t minus 3 plus 23,000. All right, why do we need to know the two functions? Well, now I need to know when will Bill and Paige have the same amount in their account. All right, so that's the next piece of this. When will Bill and Paige have the same amount in their accounts? That must mean that I need to know when B of t equals P of t. I want to know when those two equations, when those two outputs are equal. When will they have the same amount in their accounts? So write out Bill's formula. Bill's formula, okay, was 5,000 times 1.028 to the t. Now we have to fill in Paige's formula. Paige's formula was negative 2,000 over 3 times t, same variables, t minus 3 plus 23,000. All right, we're not going to solve this by hand. That looks like a huge headache. So we are going to put this in y1, and we're going to put this in y2, and let the calculator do all the work, okay? Or Desmos, or whatever you're using. I have the calculator handy, so I'm just going to use the graphing calculator. So I'm going to go to y equals. We know how to do this. I'm going to type in 5,000 times 1.028 to the x. I'm going to type in negative 2,000 divided by 3 times x minus 3 plus 23,000. We have to think about an appropriate window. I know that this came from the point 323,000. That's a lot of money, right? I'm going to want to be able to see that. So when I go to my window, first things first, I have to think about a realistic window. I'm talking about months, and I'm talking about amount of dollars. Do we have negative months, okay, when we're depositing money? There's no such thing as negative months. We're going to start the min at 0, okay? How many months might this take? Okay, remember, Paige's table went all the way down to $9,000, okay, and 24 months. So I need to get this to go, I don't know, maybe 30 months out, because I want to make sure I see the entire table. And maybe we'll change the table by 5s. All right, my Y min. Now, you can go negative in an account if you overdraw. Okay, that is possible. But I don't know if it's going to happen here, so maybe I won't touch the Y min. All right, I'll leave it at negative 10. But I know my Y max has to be pretty tall. So I'm going to make my Y max the 25,000. And then I'm going to count by thousands. Okay? And now let's see what that graph might look like. So here comes Y1. This is our exponential for Bill. And here comes Y2, which is our linear losing money. And I am in luck. I got a good window here. I can see where they intersect. That's what I want to know graphically. I want to know where those two lines are equal, or in other words, where they cross. So find that point. Second trace, number 5. Bring your cursor as close as you can. Hit enter 3 times. And I get an intersection point of 23.247968 and a Y value of 9,501.355. I want to know when, okay? The question is just when. It's asking about the months. So again, to answer this question, I don't care about this, right? To answer the question, I only need this. It's going to be after approximately 23.248 months. So after approximately 23.248 months, Bill and Paige will have the same amount of money. Okay. Now that's a pretty involved problem because you have to know your formula for the first table, you have to figure out your formula for the second table, and then you have to know how to use your technology to find what you're looking for, okay? Make sure you know what to explain what you're looking for. If you wanted to use Desmos, remember, this would just go in the first spot in Desmos. This would just go in the second spot in Desmos, okay? Y equals, and then the point of intersection will be a point that you can click on, okay? And then you can find out what that is. All right. Because this was such a lengthy problem, I might actually stop here. I think I'm going to stop here. And the next video is going to take on the other 3 that I have planned. Okay, so you're going to see 3 more word problems in the next video. All right, if you have any questions, please let me know. I'll see you in the next video.